Hello students, in today's video we are going to solve some multiple choice questions from 5th chapter of 12th physics, that is oscillations. And today's questions are from board book. You can see these questions on page number 129 of this chapter, oscillations. And today's multiple choice questions are from this textbook. What is first multiple choice question? What is first MCQ? A particle performs linear SHM starting from the mean position. Its amplitude is A and time period is T. At the instance when its speed is half the maximum speed, its displacement x is, and options are A root 3 by 2a, B 2 by root 3a, C a by 2, D 1 by root 2a. So this is today's first question. Try to understand that. A particle performs linear SHM starting from mean position. See this figure. This x equal to 0 is the mean position. X equal to a is a positive extreme position and x equal to a minus a is a negative extreme position. Particle start SHM from this mean position. Its amplitude is a, maximum displacement from mean position is a, and time period is a t, means time taken by this particle to complete one oscillation is a t. At the instance when its speed is half the maximum speed, its displacement is, means we know that in linear simple harmonic motion, speed is maximum at mean position, at this mean position, and when particle moves from mean position to extreme position, its speed gradually decreases. We have to find out that position, that value of x where speed will be half the maximum speed. For example, if speed at mean position is maximum, say 100 centimeter per second, then we have to find out that value of x, that position where speed will be half, means 100 by 2, 50 centimeter per second. So how to find out that? We know velocity of a particle performing SHM is given by this equation. V is equal to omega under root a square minus x square. We have seen proof of this equation in second video. You can watch that second video. Omega is angular velocity which is constant. A is amplitude which is also constant. X is displacement which is continuously changing. Therefore velocity also changes continuously. Velocity is different at different values of x. Velocity is different at different positions. We have to find out that value of x where velocity will be half the maximum value. Now that means here we have given that v equal to v max by 2. So keep this value here, we get this next step. Here we have interchanged the sides. Right hand side is written on left hand side, and this v equal to v max by 2 is written on right hand side. But we know velocity is maximum at mean position, and that velocity, maximum velocity, is given by this equation. We have also derived this expression for maximum velocity in second video. You can see the proof of this formula there. Keep this v max equal to a omega in this equation and cancel this omega on both sides. We get this next step. यामध्ये आपण काय केलं, व्ही मॅक्सची ए ओमेगा ही व्हॅल्यू ठेवली आणि हे ओमेगा दोन्ही साईडचं कॅन्सल केलं. टेक स्क्वेअर ऑफ बोथ साइड्स, वी गेट दिस स्टेप. ट्रान्सफर दिस a square by 4 on the left hand side and this minus x square on the right hand side. We get this next step. This minus x square becomes plus x square. This a square by 4 becomes minus a square by 4. Solve this, we get this next step. and from that take square root of both sides. Square root of 3 will be root 3. Square root of a square by 4 will be a by 2, and that of x square will be x. So this is the value of x, which is root 3 times a by 2, at which velocity of particle becomes half the maximum value. That means the answer is correct. Answer is this A. Option is A. This is the value of x at which velocity becomes half the maximum speed. ही x ची व्हॅल्यू असेल ती इथं कुठं जिथं कुठं असेल त्या ठिकाणी काय होईल तर मेन पोझिशनला जी मॅक्झिमम व्हेलॉसिटी आहे त्याच्या निम्मे होईल. आता ही एक्सची व्हॅल्यू किती सेंटीमीटर 3, 4, 5 तर आपल्याला एची व्हॅल्यू जर दिली त्यामध्ये समजा 4, 5, 6 तरच एक्सची व्हॅल्यू काढता येईल. तर अशा पद्धतीने आपण पहिलं मल्टिपल चॉईस क्वेश्चन सॉल्व केलेलं आहे. देन सेकंड मल्टिपल चॉईस क्वेश्चन. व्हॉट इज दॅट? A body of mass 1 kg is performing linear SHM. Its displacement x centimeter at t second is given by x equal to 6 sin 100t plus pi by 4. Maximum kinetic energy of the body is, and options are A 36 joule, B 9 joule, C 27 joule, D 18 joule. Now how to solve this? We have to find out maximum kinetic energy. We know kinetic energy is half mv square. Therefore kinetic energy depends on velocity because mass is constant, and we know velocity is maximum at mean position. This is the path of linear simple harmonic motion. X equal to 0 is the mean position, and these are two extreme position. Velocity is maximum at mean position, therefore kinetic energy is also maximum at mean position, and we have to find out that maximum kinetic energy. Maximum kinetic energy is half mv square, but velocity at mean position is maximum, which is omega a. So if we keep that value, we get formula for maximum kinetic energy as half m omega square a square. हा फॉर्म्युला कसा आला तर कायनेटिक एनर्जीचा फॉर्म्युला हाफ एम व्ही स्क्वेअर, पण व्हीच्या जागी ओमेगा ए ठेवलं तर हे ओमेगा स्क्वेअर ए स्क्वेअर होतं, कारण मॅक्झिमम व्हेलॉसिटीचा फॉर्म्युला आपण मगाशीच पाहिला व्ही मॅक्स इक्वल टू ओमेगा ए म्हणून ते आलं आहे. बट वेअर इज व्हॅल्यू ऑफ एम ओमेगा अँड ए? these values are given in this equation. This is equation of linear SHM which is given to us. If you compare this equation with standard equation, you will get all this value. We know that standard equation of linear SHM is x equal to a sin omega t plus phi. This is standard equation of displacement of a particle performing linear SHM, and given equation is x equal to 6 sin 100 t plus pi by 4. This is that x equal to 6 sin 100 t plus pi by 4. If you compare this standard equation with given equation, then you will get value of a equal to 6. See here, this omega angular velocity equal to 100, and phi is equal to pi by 4. Here we require only amplitude, omega and mass. And what about mass? Mass is given here, a body of mass 1 kg performing linear SHM. First of all, this amplitude is given which is 6 centimeter. This is 6 centimeter, but we want that in meter because this mass is given in SI unit kg, and amplitude this 6 centimeter, that is in centimeter, because this x is in centimeter, that's why this amplitude is also in centimeter. But you cannot take one value in SI unit and second value in CGS unit. Therefore convert that 6 centimeter in meter, that is 6 into 10 raised to minus 2 meter. Second value is mass which is 1 kg given here, and omega is equal to 100. If you compare standard equation with this given equation, then you get omega equal to 100 radian per second. Here all quantities are known. Keep these values in this equation, so we get kinetic energy Ke max equal to half into 1, mass is 1 kg, then this omega is 100, so 100 square into this a square 6 into 10 raised to minus 2 bracket square. Solve this. After solving this, we get maximum kinetic energy equal to 18 joule. So correct answer is 18 joule. Therefore, correct option is this D, 18 joule. Now, third question. Length of seconds pendulum on the surface of Earth is nearly 1 meter. Its length on the surface of Moon should be given. Acceleration due to gravity on Moon is 1/6 of that on the Earth's surface. And options are A 1/6 meter, B 6 meter, C 1/36 meter, and D 1/√6 meter. We know seconds pendulum is a pendulum whose period of oscillation is 2 seconds. And here we know length of seconds pendulum is given by the formula G upon pi by square. We have derived this formula in the video of simple pendulum. You can see there. Length of seconds pendulum is given by formula G upon pi square, where G is acceleration due to gravity and pi square is constant. Therefore, it is clear from this equation that length of seconds pendulum depends on acceleration due to gravity only. And this acceleration due to gravity is different for different planets. Here, it is given that value of this length, seconds pendulum on Earth is nearly 1 meter. What will be value of this length of seconds pendulum on Moon if acceleration due to gravity on Moon is 1/6 of that on Earth's surface? Means acceleration due to gravity on Moon is 6 times less than acceleration due to gravity on Earth's surface. So how to find out that? Here we can write length directly proportional to G, because pi square is constant. So the same formula can be written as Lm upon Le is equal to Gm upon Ge, because length is directly proportional to G. Always remember, when A is directly proportional to B, then we can write A1 upon A2 equal to B1 upon B2. Here we have taken these subscripts M and E, M for Moon and E for Earth. Lm means length of seconds pendulum on Moon. Le means length of seconds pendulum on Earth. Gm means acceleration due to gravity on the surface of Moon. Ge means acceleration due to gravity on Earth's surface. Now here, from that we can write Lm equal to Le into Gm upon Ge. This Le is taken on right hand side. From this we can get Lm equal to 1, because Le is 1, that is given. Length of seconds pendulum on Earth is 1, that is given. Also, it is given that acceleration due to gravity on Moon is 1/6 times acceleration due to gravity on Earth. Gm equal to Ge/6, or 1/6 times Ge. Here this Ge will get cancelled and we get Lm equal to 1/6 meter. So length of seconds pendulum on the surface of Moon will be 1/6 meter, and the answer is 1/6 meter. So where is 1/6? This option A. So in this case the correct option is A. This was question number 3. Then next question number 4. What is that question number 4? Two identical springs of constant K are connected, first in series and then in parallel. A metal block of mass m is suspended from their combination. The ratio of their frequencies of vertical oscillations will be in a ratio, and options are 1:4, B 1:2, C 2:1, D 4:1. So how to solve this? Very simple. Two identical springs of constant K are connected, first in series and then in parallel. We know that every spring has its own spring constant or force constant, which depends upon elastic properties. And we have also seen effective spring constant when two springs are connected in series and in parallel. How to solve this? We know that frequency of spring mass oscillator is given by the formula n equal to 1 upon 2 pi under root k upon m. When we attach a mass m to the spring and give oscillations, then its frequency is given by this formula, where k is a force constant and m is mass attached to the spring. Now in this case, so it is clear from this equation that n is directly proportional to root k because mass is constant and 2 pi is constant. From that we can write ns upon np equal to under root ks upon kp. Here ns means frequency in series combination, because here given two springs, first we are connected in series and then we are connected these springs in parallel. So when these springs are connected in series, suppose the frequency is ns, and when they are connected in parallel, suppose the frequency is np. So their ratio will be ns upon np equal to under root ks upon kp, because n is directly proportional to root k. Ks is the effective spring constant of two springs when they are connected in series. S for series. Kp is the effective spring constant of two springs when they are connected in parallel. But for series combination, effective spring constant is given by this formula: 1 upon ks equal to 1 by k1 plus 1 by k2. But here two springs are identical. That means k1 is equal to k2. Therefore we get 1 upon k plus 1 upon k, that is equal to 2 upon k. So 1 upon ks equal to 2 upon k. From that we get ks equal to k by 2, as 1 upon ks equal to 2 by k. Therefore ks equal to k by 2. So effective spring constant of two springs, identical springs, will be k by 2. We will have to keep this value of ks here in this equation 1. Similarly, we will find the value of kp. When the two springs are connected in parallel, effective spring constant is given by the formula kp equal to k1 plus k2. But here the two springs are identical. Therefore k1 equal to k and k2 is also k. K plus k, that becomes 2k. So effective spring constant of two springs connected in parallel, identical springs connected in parallel, is 2k. So kp equal to 2k, ks equal to k by 2. Keep this value of ks and this kp in this equation. We get this step: ns upon np equal to root k by 2. This ks is k by 2, kp is this 2k. This k will get cancelled. This 2 in the denominator goes in the denominator, that becomes 1 by 4. Therefore ns upon np equal to 1 by 4 under root 1 by 4, but square root of 1 by 4 will be 1 by 2. So ratio of frequencies ns upon np will be 1 by 2. So 1 is to 2. So correct option is this B, 1 is to 2. And the fifth question, what is that fifth question? See here, the graph shows variation of displacement of a particle performing SHM with time t. Which of the following statement is correct from the graph? Options are: the acceleration is maximum at time t, B, the force is maximum at time 3t by 4, C, the velocity is 0 at time t by 2, and the kinetic energy is equal to total energy at t by 4. So which is correct from this graph? The graph shows variation of displacement of a particle performing SHM with time t. Which of the following statement is correct from the graph? ग्राफ वरून ह्या चार पैकी कोणतं स्टेटमेंट बरोबर आहे? This is variation of displacement with time t. Here displacement is 0, means particle is at mean position. T by 4, 1/4 oscillation, displacement is maximum, that means particle is at positive extreme position. At t by 2 means half revolution, displacement is 0, means particle completes half revolution and returns to the mean position. Here 3t by 4, again displacement is maximum but negative maximum, 3/4 oscillation is completed and particle goes to left extreme position. This is t, and here displacement is 0, means one oscillation is completed and particle is returned to the mean position after completing one oscillation. So this is one oscillation. We have to, which statement is correct out of this four statement? Acceleration is maximum at t. We know that acceleration is maximum at extreme position. So extreme positions means these positions, this t by 4, 3t by 4, This T is a mean position. Here T means one oscillation is completed and particle is at mean position, and at mean position acceleration is 0. Therefore acceleration is maximum at T, means at mean position. That statement is wrong, because at time T, capital T, period is at mean position and acceleration is 0 at mean position minimum. Therefore this statement is wrong. B, the force is maximum at 3T/4. Again we know that this force is maximum at extreme position. Force is maximum at extreme position and at 3T/4. See, the particle is at negative extreme position. So force is maximum at negative, both at positive extreme position also and negative extreme position also. म्हणजे पार्टिकल इथं असला T/4ला असला किंवा इथं 3T/4ला असला. T/4ला असेल तर पॉझिटिव्ह एक्स्ट्रीम पोझिशनला, 3T/4ला असेल तर निगेटिव्ह एक्स्ट्रीम पोझिशनला. दोन्ही ठिकाणी फोर्स मॅक्झिमम आहे, म्हणजे बी स्टेटमेंट तर करेक्ट आहे. म्हणजे हे उत्तर आपलं येणार आहेच. पण अजून दोन ऑप्शन्स आहेत. द व्हेलॉसिटी इज 0 ॲट T/2. नाव वी नो व्हेलॉसिटी इज 0 ॲट एक्स्ट्रीम पोझिशन अँड मॅक्झिमम ॲट मीन पोझिशन. एक्स्ट्रीम पोझिशनला व्हेलॉसिटी 0 असते. एक्स्ट्रीम म्हणजे कोणतं? मॅक्झिमम डिस्प्लेसमेंट. म्हणजे ह्या पोझिशनला, ही पोझिशन T/4 या टाईमला डिस्प्लेसमेंट मॅक्झिमम आणि व्हेलॉसिटी 0. म्हणजे ह्या T/4ला व्हेलॉसिटी 0 असेल. पुन्हा एक्स्ट्रीम पोझिशन ही मिळते 3T/4, निगेटिव्ह मॅक्झिमम डिस्प्लेसमेंट लेफ्ट एक्स्ट्रीम पोझिशनला आहे. इथंसुद्धा व्हेलॉसिटी 0 असते. T/2 ही मीन पोझिशन आहे. बघा, हे 0 टाईम, नंतर T/2 आणि T ह्या मीन पोझिशन आहे. आणि मीन पोझिशनला व्हेलॉसिटी मॅक्झिमम असते, 0 नसते. आणि इथं काय दिलं? व्हेलॉसिटी इज 0 ॲट T/2. दॅट इज रॉंग, बिकॉज ॲट T/2 particle is at mean position, and at mean position velocity is maximum, not 0. That means this statement is wrong. What about the next statement D? Kinetic energy is equal to total energy at T/4. तर हे सुद्धा स्टेटमेंट रॉंग आहे. कायनेटिक एनर्जी इक्वल टू टोटल एनर्जी कुठं असते? तर मीन पोझिशनला असते. आणि मीन पोझिशन कोणती आहे? तर 0, T/2 आणि T. कारण मीन पोझिशनला पोटेन्शियल एनर्जी 0 असते, कारण फोर्स 0 असतं. त्यामुळं सगळीची सगळी एनर्जी ही मीन पोझिशनला कायनेटिक असते. म्हणजे कायनेटिक एनर्जी इक्वल टू टोटल एनर्जी ॲट मीन पोझिशन. आणि मीन पोझिशन आहे या 0, T/2 T. त्यामुळं T/4 ही झाली एक्स्ट्रीम पोझिशन झाली. आणि एक्स्ट्रीम पोझिशनला कायनेटिक एनर्जी 0 असते, पोटेन्शियल एनर्जी मॅक्झिमम असते आणि पोटेन्शियल एनर्जी इक्वल टू टोटल एनर्जी असते. त्यामुळे हे सुद्धा स्टेटमेंट रॉंग आहे. त्यामुळे फक्त एकच स्टेटमेंट याच्यामध्ये करेक्ट आहे, बी. सो करेक्ट ऑप्शन इज बी. सो इन दिस वे टुडे वी हॅव सॉल्व्ड 5 मल्टिपल चॉईस क्वेश्चन्स फ्रॉम टेक्स्ट बुक. थँक यू.